everyone, and welcome to this explainer. For all you grade 7 physical science students out there, we're about to unlock some major secrets of the invisible world that is quite literally surrounding us all the time. We're diving into Unit 4, Waves and Electromagnetic Radiation. If you've ever found yourself wondering how energy and information actually travel through the universe, well, you're in exactly the right place. So to kick things off, let's look at the essential question that's going to anchor everything we do here. How do waves carry energy and information? Just take a second and imagine how a text message actually travels from your fingertips, through thin air, and then instantly appears on your friend's phone across town. I mean, it kind of feels like magic, right? But it's totally not. It's physics. It's all about waves. And by the time we're done here, you won't just be imagining it, you'll know exactly how it works. Here's our roadmap for this explainer. 1. Modeling wave properties. 2. Sound versus light waves. 3. How light interacts. 4. Waves in communication tech. And finally, number 5. Your 5-week challenge.
All right, Section 1, Modeling Wave Properties. Let's get right into it.
Whenever we talk about a simple wave, we're really just talking about a repeating pattern. But the real key to understanding a wave's power, that lies in its amplitude. Basically, amplitude is the maximum extent of a vibration or oscillation. And here's a super important misconception check for you. Waves transfer energy, actually not matter. The taller the wave is from its resting position, the greater the amplitude. And that means it packs a much, much bigger energetic punch. Let's use a quick mental worked example to visualize this. Imagine you're tossing a tiny pebble into a really calm pond. You get those small, gentle ripples, right? That's a low-amplitude, low-energy wave. Now imagine you hoist a massive rock and drop that in. You get a huge splash and giant waves. That physical relationship between the actual size of the wave and the energy it transfers, that is our foundational concept for this whole lesson. Moving on to Section 2, Sound versus Light Waves. Let's look at how different mediums actually work. So we divide waves into 2 major categories. First up, we have mechanical waves, like sound. Mechanical waves absolutely require a material medium to travel through. So that means a solid, a liquid, or a gas. Basically, no particles, no sound. Which actually means all those sci-fi movies with massive, loud explosions in outer space? Yeah, totally fake science. On the flip side, we have electromagnetic waves, like light. These don't need a medium at all. They can travel straight through the total vacuum of empty space. And because light can travel through the utter emptiness of space, like sunlight traveling millions of miles just to reach Earth, it cannot be a mechanical matter wave like sound or water. It is a completely different phenomenon. While sound totally relies on the physical vibration of stuff, electromagnetic radiation is pure energy in transit. Okay, Section 3, How Light Interacts. Let's see what happens when it hits something. When light shines on an object, its path can change in 3 very specific ways. And this depends on the material itself and the frequency, or the color, of the light. Step 1, it can be reflected. This is when it bounces right off a surface, just like a mirror. Step 2, it can be absorbed. That's where the object literally takes in the light's energy, which usually turns into heat. Think about wearing a dark black shirt on a really sunny day. You get hot, right? Or step 3, it can be transmitted. This means it passes right through the material. And a really cool thing happens when it transmits between different transparent materials, like moving from air into water. The path of the light actually bends. So why does all this matter? Well, this wave model of light is incredibly useful for predicting everyday things. It explains brightness, and it determines color. It also perfectly explains that frequency-dependent bending between different media. Seriously, have you ever looked at a straw sitting in a glass of water and noticed how it looks kind of broken or bent? That is not a magic illusion. That's literally the light waves bending as they change speed, moving from the water into the air. Understanding these interactions lets us predict and map exactly how light behaves in the real world. Which brings us to Section 4, Waves in Communication Tech. Let's talk about the application here. Take a look at this key takeaway. Digitized signals are a more reliable way to encode and transmit information than analog signals. But what does that actually mean for us? It means that by translating complex information, like your voice on a call or a streaming video, into digital wave pulses, we can send that data across the entire globe with 0 loss in quality. It's an absolute game changer. And this is exactly where we apply this science to real-world engineering as a sort of transfer task. Think about fiber optic cables. They transmit information using super rapid pulses of light.
or your Wi-Fi router, which relies on completely invisible radio wave pulses just to connect your phone to the internet. Even computers work by converting stored binary patterns into the video you're watching right this second. As we go through this unit, you're going to see exactly how these wave properties are manipulated to build the modern world we live in. Finally, Section 5, your 5-week challenge. Let's wrap this up. Over the next 5 weeks, I challenge you to look at the invisible world around you a little bit differently. Everything we just covered today, amplitude, energy, mechanical versus electromagnetic waves, and digital signals, it all leads to one ultimate provocative question. How does your cell phone use everything we just talked about to send a single text message? I want you to keep this question in the back of your mind as we go through these lessons. You're going to gather evidence, you'll develop models, and by the end of Unit 4, you won't just be consuming technology, you'll be someone who actually understands the fundamental laws of physics that make it all possible. Get ready to master the waves, Grade 7. Have a fantastic unit.